Welcome to another exciting edition of Comet Algebra. These are the notes for 9.3, adding and subtracting rational expressions. So we get to add and subtract with algebra fractions today. Quick review of what you already know. When you're adding fractions, you must have common denominators, and then you add the numerators only and keep the denominator the same. Here, when you're subtracting, 5/12 minus 1/12 is 4/12. So subtract the numerators, keep the denominator the same, and then after you have your answer, you know that if it is possible, you must reduce it. Same strategy applies for algebra fractions. In this example, we have common denominators. They are both x minus 2, so the denominator remains the same. We're adding here, so we add our numerators. 1x and 3x is 4x. Negative 9 plus 1 is negative 8. And again, if possible, this has to be reduced, and we can tell that only if we factor both. So factoring the numerator, taking out a GCF of 4, we end up with x minus 2 being able to be canceled from both. So if you cancel both, your final answer is just 4. Take a moment if you like having the steps in the list format, and you can write down this list. In order to add and subtract these algebra fractions, first we factor our denominators, and then we look at them. From those denominators, we need to find a common denominator. And you know from your work previously with fractions, if you don't know a common denominator, one that always works is if you just multiply them. And that is the strategy we use here. You find your common denominator by using all the factors. This is very important word here. We use all of them. We don't leave out any factors when we come up with our common denominator. And so we have to rewrite these fractions as equivalent fractions with common denominators. So in this step, figuring out what we need to multiply by is the trick. And after we have them all set up as common denominators, then we just go ahead and add or subtract the numerators. And when we're done, we, if possible, by factoring the numerator, we may be able to reduce it by canceling any common factors. Okay, looking at this first example, the denominators are already factored, so that step is done. I'm just going to put this first denominator in parentheses, this x minus 3. The second denominator is x minus 1, and these are the two pieces then that will make up the common denominator for these two fractions. So I need to set up two brand new fractions with common denominator using all the factors. In this case, it's just a two-part denominator, and I'm going to write down both parts for both denominators. So the common denominator is x plus 3, x minus 1. So now we have to do the next step of figuring out what to multiply by. Well, I had x plus 3. In order to get this x minus 1, I needed to multiply both the top and bottom of this first fraction by x minus 1. I think I'm going to put that in the front here just so it stays clear. Remember, you can multiply fractions by a factor of 1 anytime you want, and we chose our factor of 1 to be x minus 1 over x minus 1. That's what got us our common denominator. And so now I'm just going to go ahead and distribute this. I have 2x squared minus 2x. Now looking at the second fraction, I'm starting with x minus 1 in the denominator, and to get the common denominator, I need to multiply the top and bottom by this x plus 3. I already did that in the denominator, so now this numerator, I'm going to distribute the 5 times the x and the 5 times the 3. So So I end up with 5x plus 15. Now I have common denominators. I can go ahead and subtract their numerators. But be careful. This subtract sign, it's like it's distributed. We easily see that we're subtracting the 5x, but we often do not see that we're also subtracting the 15. So always be careful when you're subtracting. Right, subtracting the numerators then, I have 2x squared. Negative 2x minus 5x is negative 7x. And again, this 15 is not positive, we're subtracting it, so it becomes a negative 15. And we keep the denominator the same. So we leave that in its factored form. Now, remember how I said that sometimes there's hints in the problem? Sometimes we look at these factors down here in the denominator and it gives us a clue. Well, in this particular example, it doesn't. We have to go ahead and diamond box this numerator. So to save time, I'm just going to give you the factored form. If you need any review of the diamond box, please watch the video that's entitled Factoring Review. So when I diamond box this, I end up with 2x plus 3 and x minus 5. We needed to factor it, otherwise we would not have known for sure if there was any reducing to do. But after we factor it, we look and we see we have no common factors to cancel, so we're done. If we are asked to find the excluded values for this problem, x could not be negative 3 and x could not be 1. In example 2, we take a look at our denominators and we notice that they are almost the same. The only thing that's different, in the first fraction, the x is positive and the 3 is negative, and vice versa in the second fraction. So I hope that you recognize this as a problem where we use that negative 1 trick. And it wouldn't matter. You could do the negative 1 trick on either fraction, your preference. I'm going to choose, it's a little more challenging, I think, here to use the negative 1 trick on the second fraction because we just end up with a lot of negative signs. So keeping this subtract sign, leaving that 3x minus 1, taking negative 1 out of the denominator would switch these around. It would make the x positive, so I could write that first. It would make the 3 negative. I can write that second. And now this looks nice. We almost have common denominators. I need to handle this negative 1, and there's a couple different ways. If this were an adding problem, I would just move the negative 1 up to the numerator because it wouldn't matter where the negative 1 exists in the fraction, in the numerator or the denominator, as long as the fraction has the negative 1 in it. But here we are subtracting a negative. So this is a double negative problem. Oh, that was cool. And if I want to just take care of this negative sign, I'm subtracting a negative, so these just become positive. If you're subtracting a negative fraction, it becomes positive. So now I have common denominators. I can go ahead and add these. 5x plus 3x is 8x. Plus 4 minus 1 is plus 3. And my denominator is x minus 3. No factoring to do, so that is the simplified answer. All right, in this example, I have a lot of factoring to do in the denominators. They are both diamond box problems. So again, to save time, I'm just going to do the factoring. And if I did this correctly, I ended up with 3y minus 1 and y plus 1 for the first fraction factored, and then for the second fraction I ended up with 2y minus 3 and y plus 1. So that's step 1, factor the denominators. Step 2, determine what your least common denominator is by using all the factors. Now, when we have a factor that repeats itself, like they both have an x plus 1 in them, you don't need to use it twice. So our common denominator is going to be 3 parts. It'll be this binomial, and this one. So let's rewrite our fractions with common denominators. I set up both fractions with the 3-part common denominators. So now the next step, we need to determine what we had up here in the original fraction. We had the 3y minus 1 and the y plus 1. So the piece that we need to get to the common denominator here is the 2y minus 3. So I needed to multiply the bottom by 2y minus 3 and the top by 2y minus 3. Go ahead and distribute this. So for the new numerators, for this one, I have 4y squared minus 6y. Doing the same process on the second fraction, which piece am I missing in the denominator? And for this fraction, I need the 3y minus 1 to get me to the 3-part common denominator. So we multiply top and bottom by 3y minus 1, and that gives me, we get 12y squared minus 4y. And going ahead and adding the numerators, we end up with 16y squared minus 4 and minus 6 is minus 10y. And then just to save myself a little writing here, I'm just going to represent that 3-part denominator with those 3 parentheses. The last step then is to factor the numerator to see if there is anything that can be canceled. They do have a GCF of 2y. So we factor out that GCF and we get 8y minus 5. And looking at my denominator, there does not appear to be any canceling to do. So this is my final answer of adding these 2 fractions. Looking at this last example, again going through the steps, let's factor our denominators. So the factors that multiply to 30 but add to 11 would be plus 5 and plus 6. And here the factors that multiply to a negative 24 and add to a positive 2 would be a plus 6 and a minus 4. So now the denominators are factored. We choose our least common denominator by using all the factors. So I need to use the x plus 5, the x plus 6, and the x minus 4. So now setting up 2 new fractions with those common denominators. So I have the common denominators ready. They're in the 3 parts. Ask yourself, these are the denominators we had. What piece are we missing to get to the common one? And in this first fraction, we need the x minus 4. So I'm going to put this binomial in parentheses because now I'm going to need to multiply this by x minus 4. So foiling that, we would get 4x squared. The inner product is 2x. The outer product is negative 16x. So if I did that right, I'm seeing a negative 14x. And then 2 times negative 4 is negative 8. In the second fraction, again, this is what we have, and the common denominator that we need is over here, and we need the x plus 5 in the top and bottom. So I'm going to put this numerator in parentheses so that I can FOIL it and multiply it times x plus 5. So FOILing that, we have x squared. 5x take away 1x is 4x. And negative 1 times 5 is negative 5. So now the thing to watch for when we're subtracting these, now that we have common denominators, is that this subtract sign has to be distributed to each piece of this trinomial. And we often forget that. So we have 4x squared minus x squared is 3x squared. Negative 14x minus 4x is negative 18x. And negative 8 minus a minus 5, got that double negative in there, we end up with a negative 3. And this is all over that 3-part denominator, which I'm just going to save some time representing that with the 3 sets of parentheses. So the last step is to see if we can reduce this at all by factoring the numerator. And we notice we have a GCF of 3, so let's factor that out. We have x squared minus 6x minus 1. And taking a look at that trinomial, there is nothing that I can multiply to get a 1, but yet adds to a negative 6, so that is not factorable. So this is the simplified answer, and we are done. And if we were asked to state any excluded values, looking at what would make the denominator 0, we would have x cannot be negative 5, x cannot be negative 6, and x cannot be 4. All right, now you have the knowledge you need for section 3.